Well, thanks again for the invitation to be part of this symposium. This has just been wonderful. I've been able to tune in at various points throughout the day from the central time zone here. And it's just been great to hear all the perspectives that are coming from neuroscience and the arts and education and lived experience. And all of these perspectives are contributing to great conversations that I'm not able to hear between sessions. But I think that it's wonderful to have such a diversity of perspectives informing the conversation. So my talk today is going to focus on the sensory processing difficulties people on the spectrum have, which is probably very familiar to most of you in the audience. I'm going to talk about this within the framework of a model or a hypothesis about the role of sensory issues in autism that is emerging among current sensory research called the cascading effects model. And I will go into a little more detail about what I mean by that in a slide or two. But I'm going to split the talk into basically two halves. And in the first half, I'm going to talk about sensory hyperresponsivity, which is familiar probably to many of you. This is sort of reactions to sensory input that are stronger or more negative than we might have expected. And I'd like to make the case through research from a variety of labs that these reactions to sight, sounds, touch, cascade and influence lots of more broad aspects of behavior than just sensory processing. And then in the second half of the talk, I'm going to focus a little bit more on work in my own lab, which has over the last 5 to 10 years focused on a sensory system that we might not hear as much about called interoception. And I'll describe what that is and how it may cascade to impact anxiety and other health behaviors. So what do I mean when I say this cascading effects model of autism? Well, this idea is pretty simple, and it's one that has been perhaps intuitively guiding a lot of sensory research in autism for a long time. The idea being that our brain systems for basic sensory and motor processing develop very early. So they start to develop before birth even. And then in our first few years of life, they're really heavily influenced by the sensory experiences that we have throughout our developmental years, our early developmental years in particular. And the framework that I'm going to present the data in is, basically just acknowledging this primacy, this developmental primacy of sensory brain regions and sensory development, and how these things might cascade and build on themselves to produce the complexity of the behaviors and symptoms that we see in individuals on the spectrum. So when we talk about sensory challenges, we typically talk about 3 patterns, and this comes from the work of Grace Baranek and others who have kind of talked about patterns of reactivity or responsiveness to sensory input in the environment. And the first one is where we're going to spend the most time. That's the one here on the top, which is hyper-responsiveness. As I said, this is hypersensitivity, so exaggerated or surprisingly negative reactions to what most people would consider innocuous sensory stimuli. The opposite pattern is hypo-responsiveness. This is reduced response, a lack of response to something that we would expect someone to respond to in the environment. And then there's this third pattern, which encompasses a broad range of behaviors, but they're all sort of geared towards increasing sensory input in a repetitive way or a way that is deeply engaging for the person and can be difficult to sort of redirect their attention away from. So working with Dr. Baranek initially, Dr. Claire Chen did a study using a prospective longitudinal approach where their lab recruited over 1,500 infants and then followed them longitudinally to preschool and school age and looked at, basically sort of defined these sensory growth curves for these 3 patterns. So this hyper-responsiveness, hypo-responsiveness, and then what they refer to as SIRS, which is this sensory interests and repetitive behaviors and sensory feedback from repetitive behaviors. So these growth curves showed them a lot about how this plays out over time in babies who end up with an autism outcome, either autism diagnosed autism or high levels of autistic traits, versus other groups. So the neurotypical group here, or no diagnostic group, is in the green. And then there's the purple group, which is a group that has sensory processing disorder or elevated sensory features. And then this teal group is other developmental diagnoses, things like ADHD or things like that. And so you can see right off the bat that particularly for hyperresponsiveness, but also for hyporesponsiveness, the trajectory or the pattern from infancy to school age really distinguishes people with an autism outcome from these other really similar groups. And in a follow-up study, Dr. Chen used latent growth curve modeling and structural equation modeling to look at how these sensory patterns cascade throughout development. So she looked at in these rectangular boxes are various aspects of behavior at the last time point at age 6 to 7, so early school age. And she found that the slope of hyper and hypo responsiveness had these very strong and direct relationships with later adaptive skills, motor skills, externalizing and internalizing behaviors, and that these things in turn impacted participation in activities at age 6 and 7, at home, at school, and in the community. So this is an example of what we think of as this cascade. I'm going to turn now to another study that was conducted by researchers at SDSU, San Diego State, Ina Fishman and her group. And they were focused on sleep and autism and the relationship between sensory sensitivity and sleep. And we heard a little bit about this from Dr. Bearden in her talk earlier, that these two things are closely related. So in their sample of autistic and non-autistic toddlers and preschoolers, they measured sensory sensitivity using the sensory profile and found that there are elevated levels of sensitivity in their autism group, not surprising, and that this was particularly salient or strong in the auditory realm. And then they found that there's elevated sleep latency in their autistic group. So the longer it takes you to fall asleep, the longer latency is for sleep onset. And so this is one of the specific markers of sleep difficulties. So we've all had that experience of not being able to fall asleep and trying to fall asleep and knowing you have to get up in the morning, and how distressing that can be. What they also measured was a relationship between these two things, which is something that we've seen in other studies, that since the more sensitivity you report to general environmental sensory stimuli, the more sleep problems you have overall. So these researchers were interested in trying to understand the neurobiology of this. And so in this cohort of toddlers and preschoolers, they did some imaging during natural sleep. And Dr. Nordell's talk gave you a window into what a challenge that is to conduct. These are really difficult studies to do. It takes a lot of effort and a lot of patience on everyone's parts, the researchers and the families participating. But they really wanted to understand what was happening in the brain, and try to understand what the neural basis of the relationship between sensory sensitivity and sleep was in this group. So what they did, so the sound comes into the nervous system through the auditory nerve in the cochleus, arises through way stations in the brainstem, and then travels up to the thalamus and the auditory cortex here, in pink and red. And these are the regions that they focus their analyses on, these sort of higher level regions. These are easier to image. And what they were looking at was the connectivity between these two regions. So how much is the thalamus passing information to the auditory cortex, and how much is the auditory cortex feeding back information to the thalamus as this auditory information is traveling? And what they found is that there's an enhancement in connectivity between the thalamus and primary auditory cortex during natural sleep in their autism group relative to their typically developing group. They further saw that this heightened connectivity, which is shown on the y-axis here, was related to more difficulty falling asleep. So again, sleep latency in minutes, the longer it takes you to fall asleep, the more hyperactivity you have in this circuit, that is passing information from the auditory environment to your central nervous system and the rest of your brain for processing. And so this makes a lot of sense, right? If you're not able to turn off or tune out those environmental stimuli, it's not going to be as easy to disengage in the way that we need to fall asleep. So sleep is a huge health correlate of altered sensory processing, but it's certainly not the only one. And I wanted to take a couple minutes to highlight a few others that might be a little less direct, but I think nevertheless really important when we're thinking about the link between sensory processing and health and autism. So this group of researchers in Ireland did a huge study, had interviewed several thousand adults with autism or autistic adults, and asked them about whether they go to visit their GP for routine medical care, annual checkups, and that kind of thing, and asked them about if they delayed or avoided those visits. Why did they do that? And there were a number of reasons why, but one of the things that really came up as a common theme were specific sensory challenges with the environment in the clinic. Um, so noise, crowds, bright light, uncomfortable furniture, and unexpected touch accounted for a large amount of variance in the, roughly half of people who reported that they avoided visiting their doctor for these reasons. And so you can imagine that if that is something that continues, that you could have some adverse health effects from things not being caught early enough. So that's a huge problem. We also see impacts of sensory sensitivity on mental health for autistic adults. So these researchers looked at the relationships between sensory hyperreactivity and mental health conditions, so anxiety and depression, and found significant direct effects just, by themselves. So sensory hyperreactivity is closely related with higher levels of anxiety and depression. They also interestingly measured loneliness and found that there was a mediating relationship between the sensory variables and the mental health variables. So you can imagine that if sensory hyperactivity causes you to withdraw, that could produce more less connection with people, more loneliness, and then contribute adversely to mental health outcomes. I finally want to highlight some of the work of Shula Green at UCLA and her lab. So they've done a lot of neuroimaging in older individuals, not not babies and toddlers, so autistic youth, school-age kids and adolescents. And they look at specifically at the neural basis for this hyperresponsivity. And what I'd like for you to take away from this slide is that there's multiple brain regions that are involved in this process and multiple brain regions that are related with the hyperresponsive behavior that we see in this group. So this first region, the amygdala, is a limbic region. It's important for letting our bodies and our brains know what is, potential threat or something that we want to pay attention to in our environment. And so it's sort of this is the first stop on the way to your sympathetic nervous system engaging when you feel threatened. But we also see a relationship between these reactivity patterns and other parts of the more basic sensory processing streams like thalamus and primary sensory cortices. So one of the things that Shula and her team have reported and noticed is that these regions tend not to habituate as we might expect when we have repeated sensory stimulation. So again, these are autistic youth, and they're in a functional MRI paradigm in which they get exposed to 15-second blocks of sound or touch or both. And these repeat, and it's random, but we can look at sort of over time. They do 4 of these blocks. And for our neurotypical group, they see this expected habituation or this decrease in the response of this area with time, which is what our brains are, kind of designed to do. If there's something that is repeating and there's no real other event that you need to attend to, our brains are designed to tune that out and allow us to attend to other things. But what they find in their autistic group is that the amygdala and the primary sensory cortices are less able to do that habituation. this slide is basically the same data, just split, because as you know, not everyone with autism has sensory hyperresponsivity. And so they split their autism group into people with and people without, and found that these patterns, this lack of habituation, was largely driven by people who showed the behavioral hyperresponsivity, as opposed to those who didn't. So I hope with that I've convinced you that we're learning a lot about how the brain is processing sensory signals, what the impact of hyperreactivity or hyperresponsiveness of the brain that translates to behavior that then cascades throughout different behavioral domains. I hope that that part of the story is clear. And now I'm going to shift into maybe a less intuitive or less well-known sensory domain, and ask the question: is sensory only about the world out there? Is it only about our external environments and things like touch and vision and hearing? Well, our lab recently, not really so recently, maybe in the last, between 5 and 10 years, have kind of turned our attention to this rich sensory world that's coming from inside of our bodies. And the term for this sensory input is interoception. And many of you may be familiar with this. These are sensory signals that are happening inside the body that give your brain information about the physiological condition of your body. So the speed or strength of your heartbeat, how your digestive system is doing. Is that breakfast sitting okay, or is it feeling kind of wonky? Some people consider things on the skin to be interoceptive. It's sort of, you can think of the skin as sort of the border between the internal and the external sensory environments. So all of these things are massive amounts of sensory information that our brain is getting, mainly for the purpose of monitoring whether or not our body is okay. So is our body doing all right? Do we need to drink something? Do we need to eat something? Do we need to go to the bathroom? But if these signals are being perceived in a similar way to some of the external signals that we've talked about, they may be incredibly loud, or they may not be loud enough, and they may be unpredictable, and they may be hard to manage or attend to in the way that others do. And so this could result in a lot of cascading effects. So aversiveness with food textures, or avoidance of physical exercise, or aversion to social touch, or discomfort with certain kinds of clothing, GI distress, and toileting difficulties. So this is, it's a really important, and I think really understudied aspect of our sensory processing that our lab has tried to focus on. And one of the ways that we do this is to use EKG, measuring electrical signals from the heart, to basically eavesdrop on interoceptive signals. So every time your heart beats, it stretches the tissue in the aorta, and that sends a signal up through your brainstem to this part of the brain called the posterior insula, this part in blue here. Here's the look at the EKG signal. And this will become important later, and I'll reference it again. But this R peak is basically sort of the big sort of beat that happens of your heart. And then about 200 to 400 milliseconds after that heartbeat is when we think that this stream of information reaches the cortex. And we'll talk about that a little bit later. So in our lab, we've used a battery of tasks to look at cardiac interoception. This is work that has been done largely by my postdoc, Elisa Zoltowski, who was a graduate student in the lab and has continued on working as a postdoc. And so she's helped to develop and refine 2 tasks that I'm going to tell you about quickly in looking at cardiac perception. So we have the trace from the EKG, and we present a stimulus, a visual flash at various offsets from the R peak of the EKG. And then we derive several variables. We ask them, what were these flashes of light in time with your heart or not? And we can construct these curves that essentially give us an idea of the perceptual strength of their perceived perception of their heartbeat, how temporally accurate it is, and then how precise it is. So how much variability they have in where they estimate these heartbeats to be. In collaboration with Mika Allen, who is a researcher in Denmark, we've done a similar task looking at heart rate discrimination. So in here, you're listening to tones, and instead of identifying whether each tone was coincident with an individual heartbeat, you're just listening to the overall rate and deciding were those tones faster or slower than your heart rate. And from here, we can derive some similar variables. So what is the rate at which people perceive the tones to be the same as their heart rate? So how far off do they have to be? And then precision, which is basically, again, how much variability they have in their judgments. And so if we look specifically at this precision of these judgments in these lab tasks, what we find is an interesting relationship between that precision metric and anxiety traits. So co-occurring anxiety is something that we were very interested in when we started this study, because if you recall the last time you felt really anxious, you might recall that you felt your heart beating really, really strongly, and that may sort of contribute to the anxiety. And so your perception, particularly of cardiac cues, but also other interoceptive cues, is thought to be pretty important for anxiety. So we see this interesting relationship where for a non-autistic group, the more precise they are, the less anxious they are. So the better they're doing at this task, the less anxious they are. But for our autism group, it looked just the opposite. So our autism group showed more anxiety with more precision at this task, suggesting potentially that they're just attending to it more than the neurotypical group. And this is the last little bit of data I'm going to show you. This is a way that we can get at the neural basis of this. So again, combining the EKG with EEG to try to capture the signals from this posterior insular interoceptive cortex. So we can define what's called a heartbeat evoked potential. So this is a EEG wave that is in response to this R peak itself. And it's, again, tends to be 200 to 400 milliseconds after the R peak, allowing time for it to get up through these levels into the cortex. It tends to be apparent over these frontal electrodes. And the cool thing is that you can measure it when someone is attending to their heartbeats, or when someone is attending to something else, or when they're attending to nothing else. So it's a nice thing because it allows us to use EEG, which is a little less invasive than MRI, and it allows us to measure something about how the brain is perceiving body cues without the need for attention or a verbal response. And so I think we can use this task with a wider array of this spectrum. And so we are wrapping up data collection on this study now, and these are sort of hot off the presses new data that I wanted to share with you, that we are seeing in line with this kind of anxiety and enhanced behavioral side of interoception, slight elevations in the heartbeat evoked potential in our autistic adults. We do have this data in children yet, we just haven't analyzed it yet. And so we see that at these two time points. One thing that we also see that is surprising, when people are doing control tasks where they're listening to something and having to respond to an external stimulus, we also see this elevated heartbeat evoked potential. So this is suggesting that maybe people with autism are attending to their heartbeats even when there is something else in the external environment that they've been instructed to attend to. So to kind of summarize this piece on interoception, our preliminary conclusions are that, our sense of interoception is the sense that gives us a signal of whether our body is okay. And signals like racing heart can indicate stress or emotion that can contribute to anxiety. The high precision of cardiac interoception is predicting higher levels of anxiety in autism, while we see the opposite in non-autistic individuals. So for these non-autistic individuals, predictable signals that are perceived as consistent may signal homeostasis, my body is okay, I'm safe. For our autistic group, this high precision could reflect an overfocus of attention to this interoceptive input, which might promote anxiety. We are seeing these preliminary findings at the heartbeat of a potential that there may be slight elevation in autism. More to come on that as we analyze the rest of our data. But again, we see this both when attending to the heartbeats and when attending to external stimuli. And just to underscore that this is a communication independent method. And so we're excited about being able to use this in a broader range of the spectrum than we typically can with MRI. A future direction for this. So one of the things that as we looked at the sensory effects on health behaviors, we're thinking a lot about the interoception of exercise and sedentary behaviors. So individuals with autism tend to have higher rates of sedentary behavior and lower rates of physical activity, which contributes to poorer health outcome. And we're hypothesizing that just like avoiding your GP's office for medical care, avoiding physical activity may have a sensory component for autistic individuals as well. And so we hope to be able to investigate this soon. And this is just a study in non-autistic adults looking at activities of daily life. This is sort of experience-dependent sampling and accelerometer wearing at home, and just having people record what they were doing and how much interoceptive attention they were paying. So how much was I noticing my heart or my breathing when I was exercising versus, having screen time versus, falling asleep. And so you can see that, as expected, exercise really heightens our interoceptive attention. And so if we already have excess interoceptive attention, that might be a reason why it's being avoided. So to summarize the points that I've made, so our hyperresponsivity pattern is something that's prominent. Many autistic people have this pattern, and early trajectories of both that and the opposite pattern predict autism outcomes and broader behavioral differences later in life. These come through direct and indirect effects on adaptive behavior, externalizing, internalizing, sleep onset, and engagement with settings like primary care clinics, which can have cascading effects on health. The neurobiology of sensory overresponsivity involves a hyperactive response and lack of habituation, both in primary sensory and emotion pathways. And interoception is an important sensory modality promoting homeostasis of our body and survival. And so precision of perceptual estimates in this system seems to have a different impact on anxiety in autistic versus non-autistic people. And then finally, we are seeing this emerging evidence that the brain in autism may be hyper-responsive to heartbeat signals, even when attending to something outside the body. So I'll thank you for your attention there. I don't have a slide for my lab, but I do want to thank my lab and collaborators for the data for the second half, and look forward, if we have some time for Q&A, to your questions.
Thank you, Carissa.
So I'm a parent of a teenage daughter with hyper response to tactile sensitivity. I just wonder if the search that you done is just generalized sensory. So she's very over responsive to texture, and also she has TTM, which is trichotillomania, due to her over responding to it. And we're lost. We're parents that we're lost when those things happen. So she can't wear socks, she can't wear underwear, she can't wear a bra. All her clothes are very baggy, 3 times the size. So we just don't know where to go from here, what kind of program to look for. She has issue with sleep patterns. She wakes up in the middle of the night pulling her hair. So I just wonder if you have any information on that.
Yeah, thank you for that question. It's such a important and poignant illustration of how much these sensory issues can impact people. And I think, one of the things that we're hopeful about is that by learning a little bit more about the neurobiology, we may be able to develop treatments. I think I hope that you have access to an occupational therapist. I think that is something that has helped a lot of people with sensory issues. The sensory integration therapy and other sort of related therapies by OTs, there's a growing but still kind of lagging body of research behind how they work. But for a lot of people, you just exposure in a controlled way, in a way that is informed by a deep understanding of how the brain processes sensory information can be really helpful. So I feel like if you're not already connected with an occupational therapy clinic or services, that would be my first recommendation. And then, I think that, beyond that, it's like all of us parents, that you just try things. You're just try, you've discovered that she can tolerate clothes that are baggy. And so that's a step, right? And so building on those steps, is important. It's important to acknowledge the successes that you've already had.
Yeah, thank you. She is an occupational therapy program already. But it's just, like you said, there's not enough research or people, doing, what are you doing? And it is just, as a parent, it's tough to see your child suffer because she can't control why she's having those reactions. But, I really thank you for you being here and sharing, your research. Thank you.
Well, thank you. Yeah. And I hope that we can continue to understand this better so we can help people like her.
Okay, so I hope I got this right. But so if, our whole kind of wellness culture is focus on your breath, focus on your breath, focus on your breath.
Yeah.
If autistics are actually more aware of their heart rate and that increases their anxiety, might that be actually bad advice for our autistics that we love?
That's such a great question. So I want to answer the question, but I want to also acknowledge the limitation of my ability to answer it. So this research the research that I showed is looking at cardiac interoception rather than respiratory. And there's some important differences in that, right? Because your cardiac, for most people and to most of the extent, your cardiac signals are not something that you have conscious control of, right? But your respiratory signals are to some extent, right? You can choose to breathe faster or slower. So you have a little bit more voluntary control there. And I think that difference can really make a big difference in, what I would expect to be the relationship between the sensory signals and the anxiety. I guess the other caveat I would say is that, the research that I'm showing you is based on averages. Each individual person is different. I would certainly say that if mindful breathing if it seems to be helpful or even just not hurting, I certainly wouldn't discourage it in any way.
Just really quickly, I know we have to wrap up, but when I was an undiagnosed autistic kid, I was aware every day when I would be on the school bus that my heart was thumping out of my chest. And I had no idea why. I had no idea. I was like, look, I can watch my shirt move. My heart is, pumping so hard. But I didn't connect it, and nobody knew how to connect it for me to anxiety, sensory overload, all the things that I was experiencing. And I just think that sometimes if kids know, even though it's a problem, if they know, instead of being bewildered, like, am I dying? Am I having a heart attack? They know, like, this is anxiety because you're in sensory overload. That's a good thing to, like, convey to kids. That's just my thought.
I appreciate that comment so much. And I think that one of the things that we're really interested in understanding better is how the context and how we're interpreting the context of our interoceptive cues influences how we think about them. And, my Elisa, the postdoc who did a lot of the work that I showed you, often likes to say, like, if your heart is thumping and pounding, but you look around and you're on a treadmill at the gym, that's a very different conversation than if you look around and you're in a dark alley and you're not sure if you're safe, right? And so understanding why is a really important element of interpreting interoceptive cues.
Thank you so much, Carissa. I think the other thing around this presentation is that work along these lines around people understanding or talking about their internal sensations. I think it's also helping to break down some myths that have been perpetuated in the community, like autistic people don't feel pain in the same way. Like, there is this internal recognition, as you're saying, of what's happening in their body. And they can report on it sometimes. And I think it's also important to understand and recognize that we're not just talking about the external sensory world, but what's happening, what are people feeling within themselves. That's really important. So thank you for the work you're doing.